Good day, everyone. Okay, so our topic for today is charge, current, and time. The aim of today's lesson is for you to understand the relationship between charge, current, and time. So, objective of today's lesson is, at the end of the lesson, you should be able to identify what a charge is, define what a charge is, and what is meant by electric current. Okay, so let's start from electric current before going to charge. Remember that an electric current is the flow of charge. Electric current is the flow of charge. So when electric touch is on, millions of electrons pass through the touch bulb through the cell, okay, every second. So each electron carries a negative charge, that's why I call it electron. The current in the circuit transfers energy from the cell to the touch bulb, okay. So the size of these electric currents is the rate flow of electric charge. The size of electric current is the rate of flow of electric charge. So this is the flow of charge per second. Current is the flow of charge per second. The bigger the number of electrons that pass through a component each second, the bigger is the current passing through it. So what does that mean? Now let's go with the definition and let's explain it mathematically. If we say the size of electric current is the rate of flow of electric charge, that means electric current. And again, we need to know how do we represent all these electric current, charge, and everything. Electric current, which is represented with I, capital I, is current. Okay. So charge, represent that as Q. That's charge. Okay. And we have time, which is T. That's time taken. Okay. Current is measured in amps. Capital A. Charge is measured in coulombs. And time is measured in seconds. Okay. So now with the definition, it said the size of electric current is the rate of flow of charge. That means electric current is, is means equals to, okay, is the rate. And what do we mean by rate in mathematics? Rate means over time taken. That is rate, over time taken. So rate is over time. That's I equals to over time charge, and charge is Q. Okay, charge is Q. That's rate of charge. That's Q over T. That is how to represent current. But remember, we want to look for charge. Okay, so looking for charge, we cross multiply. So Q times 1, we have Q, and I times T, we have IT. So that is why charge is represented as IT. Remember that Q is measured in coulombs, I, which is current, is measured in amps, and T is measured in seconds. Okay, so Q equals to IT. So charge flow is the current, is the charge equals to the current multiplied by time taken. So Q equals to IT. Now let's have an example here. A charge of 16 coulombs passes through a bulb in 5 seconds. Calculate the current through the bulb. Remember, from here we have I equals to Q over T. So that means even from here, we have make I subject to the formula. So in the question, we have a charge of 16 coulombs. So that's Q equals to 16. Okay, and it passes through this bulb in 5 seconds. So T equals to 5 seconds. Okay, calculate the current. Now we want to calculate I, which is the current. So I equals to Q over T. So I equals to Q. And our Q here is 16 over 5. That's Q over T. So I equals to, now what is 16 over 5? 16 over 5 is 3.2. So we have 3.2 ampere. Remember, we have 3.2 ampere. So that is current. Now we have another question here, which is The question is, how much charge, from the word how much charge, that means we want to solve for Q, okay, flows through a resistor in 2 minutes. That's time taken. Remember, our time taken is measured in seconds. So if we have 2 minutes, so what is 2 minutes in seconds? 2 minutes. Remember, 60 seconds make a minute, right? So 2 minutes will be 2 multiplied by 60, okay? So which is 120 seconds. That's 120 seconds. Okay, if it carries a steady current, and that is current which is high, of 3 amps, that's 3 amps. Remember that the formula to calculate electric charge is Q equals to IT, where I is the current and C is the time taken. Okay, so I, which is the current, is 3 amps, while the time taken is 120 seconds. So 3 times 120 gives 360. And remember that the unit of charge is coulombs. Okay, so the unit of charge is coulomb. So the main thing is, I just want you to know what is a charge, a current, and the relationship between them. The current is the rate at which charge flows. So charge equals to IT. I is represented as the current, T is the time taken. So that will be the end of today's class. In our next class, we continue with the relationship between the V and I R. Okay, so thank you for watching. Please don't forget to click on the subscribe button. Bye.